So, we will start from the new unit, the last unit of this course. Okay. So, we completed the majority welding processes we widely use for metals and alloys. So, there are some special processes we use for soft materials, non-metals, okay. So, especially for plastics, and these processes are also very important because the volume at which these processes operate is also very important to understand the principle behind this process used for joining plastics, right. So, we will look at in this last unit the processes that are commonly used for plastics, right, for both types of plastics. Okay. So, what are the types of plastics generally we in which we classify plastics? Two classes, right. Okay. So, thermosetting polymers, and then what are the difference between these two? Yeah. So, once you process, once you melt and shaped into a given design, the thermostatic polymers cannot be remelted and then reworked. Examples? Backlight, for example, and then so vulcanized elastomers, for example, tire, rubber, vulcanized rubbers. So, recycling can be very difficult. So, once you make it. So, generally the thermosetting polymers are difficult to join. Okay. So, we will have to either use adhesive bonding or mechanical fastening. Whereas, in most of the engineering applications, if you look at which the plastics are used in automotive applications, can you give an example where it is used in automotive? Dashboard, for example. Lamps. Okay. So, if you have two-wheeler, the indicator lamps, those are plastics. Okay. Those are thermoplastics. And the recyclable, we can recycle them, and these thermoplastics are widely used in engineering application because you can join them easily, right. So, you can use a simple joining method, what you are going to look at in this class, to really advanced joining methods, and we can also use them to make the parts out of these thermoplastic polymers. Can you give example of thermoplastic polymers? Polyethylene, polypropylene, PVC, polyvinyl chloride. So, these are all very commonly used thermoplastics for engineering applications, right. So, we look at one by one. Before that, the classification, as I just explained, so you can classify into the two types of polymers, thermosetting and thermoplastic. Okay. Thermosetting polymers are very difficult to join, forget about it. So, thermosetting polymers, so once you melt them and then cast them into a design, it is very difficult to join them, or you need to make an engineering component out of it and further work with that. So, majority of thermosetting polymers in engineering applications, when you want to join, we use adhesive bonding, right, or mechanical fastening. Most of the cases, if you look at thermosetting polymers, the components that are actually used in engineering application, that is the final shape. So, it is almost like in a net shape casting, molding is done, these thermosetting polymers, and then those components are directly used in engineering application without any joining. So, we generally avoid because of difficulties in joining them using say for example, the methods we use it for thermoplastics. So, thermoplastics in other hand, and they can be joined and using a various processes that we are going to look at in this class. Okay. For example, we can use thermal methods, like so the methods like the hot plates, hot gas, hot tools, extrusion processes, laser based processes, or infrared optical welding processes, or you can also use friction welding, like we looked at in last class, right. Whip blade process was developed mainly for polymers, plastics, right. So, you can use friction to weld polymers, or ultrasonic transducers, ultrasonic welding, what we use it for metals and alloys, we can also be very well used for plastics, right. And also you can use then some the induction processes, electromagnetic processes, resistance, induction heating, microwave heating, or dielectric heating, right. So, we look at first the welding process or the joining process are used for thermoplastic polymers, and then we look at the major welding process, joining process used for thermosets, that is adhesive bonding. right. So, first very simple process used for joining of plastics is using a hot plate. Okay. So, I do not know how many of you have seen nowadays plumbers working with PVC pipes. Okay. What do they use to join pipes?
I was in MIP.
Okay.
So, they use adhesive generally.
Generally they use adhesive. So, the thermoplastic polymers, the most easy way of joining them is to heat them up and then apply some pressure, join. Okay. So, using a hot plate. Okay. It is also known as hot tool welding or mirror plate and butt and fusion welding processes. So, the method is very simple in hot plate welding. So, you have a heated tool or plate, okay, that goes actually inside the fairing interface to be joined, right, and then you melt the interfaces, right. So, you have a heated tool, the joints to be welded are heated up at the interface using a hot plate, and subsequently you apply an upsetting pressure. So, you also create some seam. So, this is the most commonly used joining method used for thermoplastics, hot plate or hot tool welding. Okay. So, this process is very simple. So, you apply some pressure with the tool and then tool is withdrawn. This time is very critical, generally it is about 3 seconds, not more than that. So, if you leave the time interval more than a critical limit, the molten interface would solidify immediately, is not it. So, you will have to make sure that, so the tool is heated and the interface is molten and the tool is removed immediately. Upon removal of tool, you do an upsetting. So, in this process the interfaces are joined and you create a flash and then interfaces are molten, and this is very simple process because thermoplastics can be molten a number of times compared to thermosetting, is not it. So, thermoplastics can be welded very easily using a hot plate, right. Good. Then there are a lot of variants of hot plate welding if you look at it. Okay. So, one of the simple method I showed you, and you can also use the hot plates with the proper fixtures and clamping. Okay. So, this is a heated plate and welding process. So, where the components to be welded are held with a fixture. Say for example, in this case you will have to weld such an L clamp, the L frames. So, you hold it with a proper fixture and then a hot plate is inserted between the components to be welded, and then the fixtures are brought in together. Okay. After heat plate is inserted and then you apply a pressure, okay. The hot plate is pressed against the parts to be welded and then you melt the interface. Subsequently, you remove the hot plate and then you apply again another pressure and then you have a solidification of the interface forming a joint at the interface, isn't it. So, it is the same as the one you saw in previous slide. So, in this case with the proper clamping, right, the hot plate welds are made using a simple molten tool, hot tool. It's clear? Okay. So, what are the advantages of this process? Is very simple, very economical, right. So, you do not need a really complicated heating mechanism like you see in induction welding, or it is not messy, it is very simple process, right. So, it can be used to weld large parts or even small parts, flat, curves, any complex geometries can be welded, right. And the other main important advantage is the surface irregularities. So, you need to have a proper preparation of the surface. Adhesive bonding, preparing surface is extremely important, and we will have to sometime do cryogenic treatment. Okay. So, the surface has to be polished very well, and then it has to also be treated in dry ice -10 degrees. Generally we do it in our lab as well when you are doing adhesive bonding. So, those kind of complex preparations you do not need, because you take a hot tool, press the hot tool against the interface, and interface is molten, and then subsequently remove the hot tool, press it again, and then you have a solid joint. Okay. So, the materials with different melting points can be welded by using different heating tools. You don't need to use the same tool. So you use one tool and for bottom joint, bottom interface, the other tool for top interface, and then you join together. Yeah, and you can also automate the process easily. Right. So yeah, I mean these processes are automated very commonly. One of the most of the automotive components, for example, indicator lamp, you have an orange top and then bottom white thing, right? So those two are joined by the hot plate welding. Okay, and if you look at how many of you use the shavers, for example, shavers, the plastic mount, those are all hot plate welded. So there are some disadvantages of this process, like for example, you need to have a long cycle time, okay, and then high temperature are required, and sometimes you generate fumes which are carcinogenic. Okay, so when you melt and then you generate fumes of polymers, and those fumes has to be properly recycled or can be captured and then sent out. So otherwise the polymer fumes are carcinogenic, right? So sometimes the plate itself get degrades because the molten polymer can get stuck to the plate itself. Then plate has to be regularly removed and cleaned. And you always get flashing because you melt the interface and then subsequently you do an upsetting. So you always have a flash forming that has to be machined off and do this process. Yes, it's clear. So the technology wise is very simple. You melt and then heat up and then press it, that's it, job done. Good. So the material wise all the thermoplastic polymers can be used. So this is the one I am talking about. So this is very commonly joined. If you look at the two parts, isn't it? So the vehicle lamps, and those are all hot plate joined. So this the bottom one and top one, they are actually joined at this interface. So these two are the prior joining interface, and you make a hot plate tool similar to the configuration what you want, and then these two are different polymers, right? So each tool can heat up the interface to the required temperature, and subsequently tool is removed and then they pressed and then you form a flash, and the flash can be removed easily, right? It's clear. So we can use it for any thermoplastic polymers, this process, but often widely used for slightly softer, because then you reduce the upsetting pressure you need, okay. For polypropylene or polyethylene, it's not suitable for nylon or high temperature, high molecular materials, because you need to heat up higher temperatures, okay. And if it softens much easily with respect to temperature, then you can also not use it because the entire structure will collapse, right? Good. Any questions so far in this process? Yeah, so semi-crystalline thermoplastics, they become extremely softened. Okay, so you need to have the component itself should have some strength, otherwise how do you do an upsetting? Say for example, the example of semi-crystalline polymer is some sort of flexible rubber polymer. You can't use that. Okay, so collapsible rubber tubes. You need to have some upsetting, right? So otherwise, how do you do an upsetting force? The is already in a collapsible. So if you melt and then it doesn't have any mechanical strength at all. So for semi-crystalline thermoplastics, now it has to material has to use have some strength, okay. So this process, that's why it's very commonly used for polypropylene, polyethylene, okay. So nylon, it's not possible because that will collapse, okay. Good. So what are joint designs we commonly use for hot plates? Simple butt joint, and you can also increase the area, okay, so that the weld strength or joint strength increases at that area, okay. And you can also do a double flash and a skid joint, okay. So this also, skirt joint is also commonly used for polymers, right. Good. So we'll move on. So we'll just run through. So this is one of the completed flash but fusion weld. You see, this is the PVC pipe. Okay, so PVC pipe, the joint is made using a hot plate weld.
So similar way, another seam will be there inside the.
Inside will also be there.
Okay, that
Yeah.
cannot be made.
It can be removed. So generally, the tool with an umbilical goes inside with an orbital machining. Especially if the pipe requires to maintain the flow of fluid at a given velocity in an engineering application, which are really important, then you can send the orbital machining tool, go inside and then machine it off. But generally these kind of PVC pipes are not used for applications which requires precise control of flow inside the material. For example, plumbing, regular plumbing application, you don't need to remove flash. Okay, so you can very well use a flash inside, and even flash outside also. It looks good, isn't it? Yeah. So the PVC pipes, now we can use a hot plate to the weld the joint, and sometimes then if you buy a PVC pipe for plumbing application, you would see the weld, but once the flash is removed, it's very difficult to identify where exactly the joint is. Okay, so it becomes highly integral part of the pipe itself. But if you look carefully, you can see the seam, weld seam. So whenever I see some structure weld is there, I always go and look at that, stare at it. Similarly, in PVC pipes for plumbing, if you look at most of the cases, you can't buy one single seamless PVC pipe. So you may see some joint. So most of them are the butt joints. Okay, so if you remove this flash, and you don't see much of the joints. We can use the hot plate welding to join the PVC pipes as well. This is also commonly done. Okay, and there are some modifications of the process, especially the welding is joinings to be done over a long seam positions. So we also modify the heating tool. Say for example, in this case, the wedge heater is placed at the interface between two joints to be made. So this is like in a long seam welding. So you have to join two long plates in a longitudinal seam. So what you do is you place a resistance heated hot wedge at the interface. You heat up the interface, and subsequently the rollers roll it, and this is leveling rollers. Okay, and then this is driving rollers. Okay, so driving rollers rolls, and you heat up the interface using a resistance heated wedge, and then the wedge moves, and subsequently the interface melts, and you have a levering roller and then the work roller. Work rolls, you just move along the interface, and then the interface, the molten interface comes into contact with each other, and you apply the pressure by these drive rolls. Subsequently you can make seam joints, right? It's clear. And yeah, this unit is also commonly used. I may have a picture of that. No, okay. And this is commonly used to the weld thermoplastic plates, especially the thin section plates, right? So for varying applications, we may need the polymers. For example, you'll have to cover a table with a plastic coating. So then you'll have to join with a seam joints, right? So the principle is very same, the simple. Instead of hot plate over there, you have a heated wedge. And wedge travels at the interface, and it does heats up the interface by radiative heating or convective heating. The interface is molten. Subsequently, the roller, which follows the molten interface, and then applies some compressive pressures, compressive forces at the interface, and the interface coalesce and form joint. Right? It's clear? Good. Okay, so these are some modifications in hot plate welding. The principle is very same. You always have some tool which heats up the interface, and the tool geometry can be anything. The principle is use the heated plate, melt the interface, apply some force, and then form a joint. It's clear? Okay. So other process we also commonly use to weld, especially if the welding cavity is larger and you'll have to fill more volume at the interface. If the base material is thicker, then we also use a process known as hot gas welding. Okay. So, hot gas welding, the principle is again interface is heated up. In previous case you used a plate, right. So, in this case, so we use an hot gas or hot air. Okay. You melt the interface, and we can also simultaneously add some filler, right. So, this filler goes in, this is the hot air tool which sends the hot air and then melts the filler as well as heat up the interface, and the molten filler subsequently deposits at the weld cavity. It is like GMAW welding, isn't it? So, what you do is you have a hot air, it melts the filler, deposits at the faying interface, right. It's clear. And the filler can be low melting thermosetting polymers, or we can also use thermoplastic polymers. Okay. So, but thermoplastic polymers generally they are less strength than thermosetting polymers. So, we can also melt and deposit the polymers and then make a joint. So, what are the advantages? If you look at the process itself, I may have a picture. No. Okay. So, what are the advantage is compared to the other processes of hot gas welding is a simple and economic, like again the low cost and light and easy to weld in awkward positions, because you can also reach the position which are actually not reachable by hot plate welding. It is also widely used for repair, field repair. So, you can use a filler and then hot gas to melt the filler and then deposit at the area which is broken. Okay. But there are some disadvantages like long cycle time, and in order to do an hot gas welding, welders will be certified. Okay. So, otherwise not everyone can do that. You can also use expertise from the welders to make a joint, but the welders would be certified. Unless certified, you can't use it. And most of the welding applications, unless the welder is certified, and you can't use anyone else who are not certified to make a component. Otherwise, if the component fails, and you are in real soup. Let us move on. So, again the hot gas welding also we can use it for polypropylene, polyethylene, PVC, acrylic, polyamides, and all other polymers which are thermoplastic. Okay. So, this process is very commonly used for chemical storage, ducting, film extraction systems. Yeah. So, the repairing automotive bumpers, we use it with hot gas welding. So, if your car is you hit someone or some tree or something like that, your bumper is broken. So, the bumper is repaired most of the cases. Again, how many of you seen, I do not know, in auto shop and garage, bumper repair. So, bumper repair is done majority by hot gas welding. So, you would have an hot gun with a filler, and then you go and look at it. I mean, you break a bumper and then take it. So, if you look at repair, the bumper repair is done always with hot gas welding, because you can add extra material, right. Good. Nice. So, we will move on to the joint design again. So, the advantage of using a filler gives us to manipulate the joint design. So, we can use the conventional bevel, V groove bevel or double V bevel. What is bevel? So, bevel is a joint design, so machine design. So, this is V bevel. Okay. We will see next class some of these aspects, and this is double V bevel, and you can also use a K bevel. What is K bevel? Something like this, right? Right? Good. Okay. So, we can weld in T joints or corner joints. We just add extra filler, right? Good. We will move on. So, we can also automate the process to make the longitudinal seam joints. Again, the principle is same as you do it in hot plate welding. Only thing is here we may add a blower and then a filler. It can be sent to the joint. Subsequently, you can fill, and the rollers can apply pressure to get the filler joined with the interfaces to be welded. Right. So, it is not real complex in terms of process itself. The principle is same. The blower and the heating unit heats up the filler and filler melts and then solidifies subsequently roller can press to make sure that the interface is molten and mixed with the filler. Okay, good. So then the next the process which are commonly also used for joining plastic is extrusion welding. Extrusion welding is it is like an injection molding. Okay, so the molten thermoplastics okay, is injected or extruded into the joint, right. So in this case, for example, this is the joint to be welded, isn't it? So what do? You have a tool which can extrude the molten thermoplastics into the joint, and subsequently the joint can be solidified to make a joint, right. So this can be similar material or dissimilar material. And most of the polymers, thermoplastic polymers, you can use even a dissimilar, because they have a good so what do you call so I wouldn't call that they have a good mixing behavior, but you can say that even if you use polyethylene or polypropylene, the joints would be significantly integral. Okay, so it's even dissimilar filler can generally used for welding plastics, and you can also use similar fillers. Okay, so in this case we can take, if it is polyethylene, you have a polyethylene extruder, and this extrudes and then fills the weld cavity, right. So we can also use a nozzle to all the simple extrusion tools. For example, you can fill the filler and then can be extruded and then placed, and this is the leveler, okay, which levels the top surface, and then subsequently the entire thing can be moved either this way and this way. Good. So the advantage of extrusion welding is now you can do it in a continuous seam in a single pass. You can fill large amount of weld cavity. Okay, welding time can also be faster, and you can deposit more volumes. Even thicker section can be done, and this is really a heavy equipment. So most of the thicker section polymers, for example water tanks, those are welded with extrusion welding. Okay, so something like this, you have an extrusion gun, and this is an thermoplastic. So you will have a gun which is really heavy. It's about 12 to 15 kilograms or so, and these are parts, and you add the filler extrusion material, and it is extruded and then deposited along the weld joint. So the thicker section welds are possible because you have a more volume of material can be extruded to the joint and using a simple gun. Okay, so the gun looks like this. I mean, it is like you have an hydraulic cylinder which actually pushes the molten material into the tip, and the subsequently tip can be can deposit the extruded the filler onto the weld cavity, right. Extrusion welding. So the most of the cases the cylinder works in hydraulic principle, and there are some pneumatic also there, where you have a hot air or the compressed air which actually pushes the cylinder to extrude the hot polymers. Okay, so because of the gun itself is heavy, so you need a reasonable strong man or woman to weld using an extrusion welding in polymer. Generally vertical welding is difficult because you have to hold the gun, right, something like shooting in the sky, so it can be very uncomfortable. So that's why the welding is generally done with a downhand weld. Okay, so again the welding corners can be tricky because gun itself has to be manipulated. Okay, and again so it needs a proper training. Not everyone can do that because the hydraulic pressure what it actually carries, it can be tricky, and you'll have to move along the weld seam. So you cannot do here and there, right. So you have to make sure that you track the seam and you deposit along the seam, right. Good. So what are the common thermoplastic polymers can be welded is again polypropylene, polyethylene, PVC with a large mass. Okay, so heavy thick sections. Okay. So PVC has a very narrow processing temperature range, although it solidifies very quickly. You have to do it very faster. Okay, So the extruder should be purged after each weld run, otherwise it can clog. Okay, so the extruder can be clogged within molten PVC. Okay, so you can use it for a large fabrication like tanks, water tanks. They are all, again, go and look at syntax tank, the seam, and you see an extruded welded the joints. So heavy thick sections, about more than 25 mm plates, those are all welded with extrusion welding. So mainly used for plumbing applications, for agriculture applications, for water transportation and water storage. Those are all extrusion welded. Okay, good. So some of the joint designs, generally it is done in overlap configuration. Okay, so because you need to have some filler, and then you make the filler flow along the overlap sheets. Okay, so the butt joint is not addressable, because then you butt joint, you filler it, you fill it with the filler, then the mechanical strength of the joint is poorer than you use an overlap joint, overlap with fillet. Okay, so VW butt joints are also possible, but most of the cases this welding is done in overlap configuration, right? Good.